This talk is a bit our journey towards like automating ingestion pipelines. So I'm Alex. I'm a lead architect at VP. It's like a retail company in Europe. I'm also lucky enough to be like a Google developer expert. It's just a bunch of geeks actually. So I'm going to start with the Middle Ages. Our first attempt to actually drive our ingestion pipelines through a small team. We don't want to write like ETL pipelines for like 60 microservices. So we want to do like a lot of things automatically. But we have gone through a few iterations. We'll start with that one. Then Proto Beam, I talked about that in Berlin. That's like the industrial revolution for us. So it's not the end goal. Something in between, it's like a schema registry that we use as a matterstore, and then everything coming together in schema lab PCollections. And then at the end, I go over the complete use case. So historically, the Middle Ages. Well, actually before the Middle Ages. So we started out with ETL. You have like a SQL Server cluster, cluster, 2 machines. You start with ETL scripts, big, so move it to Hadoop, and Hadoop was then used to dump our data into BigQuery. We already started with BigQuery in the beginning, but still, it was tedious. But yeah, that's how you start. We were fortunate enough that we were going to redesign our system. So we want to have from our monolith to microservices. And as we were kind of a stable team, we all like actually sat together and say, hey, we have data needs, hey, logistics has those needs and those needs. So before we actually started, we said like, what are we going to do? So one of the things that I thrown on the table was, let's go for a gRPC. Then we have like protobuf, and then if we go then over the wire, over the bus, async communication, we can use also protobuf over there. So I do have like only a partial win, as like most of the company was using .NET. gRPC at that time was like, they were not really comfortable about those things. Although in this last year, a lot of things have changed. But I'm talking about 2 to 3 years ago. So, but at least I had one win, and that was like using protobuf over PubSub for async communication. So we built our microservices. We had like our pipelines. The protobuf comes in. Protobuf, for the one that doesn't know, it's like who actually don't know what protobuf is? Yeah, but yeah, I'm not going to explain for you, sorry. So that's good. So we use those to actually get our data into BigQuery without doing anything manually. So we used actually the magic of the descriptor of a protobuf. That's like the schema that's compiled into a binary proto itself, and that drove actually our pipeline. So if you go like a few protobuf description, and you go to proto-say, it's a tooling that makes like the contracts. You have like a Java class with a descriptor. So everything is linked together. We did with, so the protobuf came into our Beam pipelines, and we did some naive schema traversal to get our BigQuery schema. So what did we do? Protobuf message came in. We saw what is the first element. Is it an int? No, it's not. Is it long? No, it's not. Ah, it's a string. Okay. Then we create our first element in our table row, and so for everything. Actually, it worked pretty well. It made sure that our pipelines were automatic. I said like there were 60 microservices, so otherwise you had to like create an ETL pipeline for all of these microservices. We had pretty good, decent support for BigQuery, Bigtable as well, Spanner, and Elasticsearch. So microservices produced data streams, and we could like put it in those things, only driven by a configuration file. But it had some problems. So the problems is that while you had like your system automatically from a contract that was protobuf at the end automatically into BigQuery or something else, you had a massive configuration file. So you actually move your problem in from code to configuration. It looked a bit like this. So for a certain microservice, for that entity, what is the clustering column for BigQuery? What is the time partition? If you want to get it in Bigtable, what will be the row be? Do we need to reverse it, for example, for not having hot spotting and so on? So that grew and grew and grew. So our configuration file was massive. So we actually moved a bit the problem to another side. And we had to do that actually for development, production, staging, and so on. Another problem was, hey, you were dealing with humans. So the proto, it's like nice theoretically if you go contract first. But as we are like the majority of the people, we don't want to do contract first. So they're quite used to creating REST endpoints for the microservices. How do they do that? Create .NET classes and use the Microsoft tooling. And from there on, their REST API was created. And they wanted to do actually exactly the same for what's sent asynchronously. So what did they do? They did the effort of creating a .NET to proto schema compiler, so they didn't have to write any contract. But yes, of course, that leads to flaky interoperability because they're changing their classes, and of course, without noticing, they're changing like a string into an int. That maybe works in a REST interface, but in proto, if you want to change something from that to that, it all breaks. So after a while, we ended up like they call us actually the data Nazis, because as soon as there was something broken, we were at that desk and saying, this broke, you broke incompatibility, and so on. So although we like a nice format, if you don't go contract first, where you have some safety nets, you end up with those things. So at the end, we had something nice, kind of driven, but it had some problems, like configuration file and the flaky contracts. So we had to do something about it. So the first building block is what we did, like tackle the configuration issue. And that we do with Proto Beam, and we did immediately do that in open source. It was with the experience what we did with our proto contracts. We said, let's start over there. Keep focus on ingestion. Still no complex transformation. Bidirectional, because if we want to get like something into BigQuery, actually you want to do the reverse as well. If you then do a query from BigQuery, you want to get the proto contracts out as well. So we could like use universal code. And remove the configuration hassle. And how did we do that? So first of all, we focused also on the performance. So it was a bit better. Instead of like for every message do a tree traversal, we said let's make like a planner. So you have your proto descriptor, something binary. Let's create a plan. So for the first element, it's a string, so we know about from it's a string. So if we then do for each element a tree traversal, we don't have to decide what kind of type it is. So it's much faster. We also tackled well-known types. For Proto, you have like timestamps, you have wrapper types and so on. Wrapper types are kind of nullable types. We also blend that, and if you then go to a BigQuery with a nullable field for those things, the timestamp was a timestamp. So that was for a performance thing, and with the plan, it was a nice thing that it was bidirectional. But the most effort that we put into was like using options. Proto has like a very nice concept of options. That means that you have like a fields, you can annotate them. That's like, if you're using Java, it's like very compatible to an annotation. And in Python, it's called decorators or something. It's very compatible. So we actually wanted to move our big configuration file, actually stick those metadata on the context itself. So it looks a bit like this. So it's like a big contract. Things like in black and red are options. What's nice in Proto is that it's type safe. You can provide them upfront, define them upfront, and so it's not just a string of text. No, it's like really typed as well. So this is an enumerable, this is an int. Don't put a string here. If you put like something else there, that's not in the enums lists, it will break. Well, it just won't compile at all. So that brings together the configuration. Actually, it merges the contract with the configuration. So that made it a lot easier. And because it's like you could put those things in the logic of the tree traversal, where you see this has like the BigQuery day partition. That means that we need to configure in BigQuery it's partitioned per day by time code, just by putting like an annotation like here. Then the clustering 1, 2 makes cluster by to count in case. But you see, it's nice. It was kind of working for us, but Beam was kind of moving towards something else. Because the schema is here like kind of outside of your Beam pipeline. You had like your Beam pipeline that read from PubSub. Then we had like actually a transform that knew what the schema was, but it was all brought in from the outside. What if we could like, by the way, it's open source. Don't use it because there will be stuff better at the end. But what could happen when we could actually have the schema inside? Probably if you had like a few Beam talks already, there's like a lot of talk being done about schema-aware PCollections, and it's like making sure that the schema is inside. So, but first, another building block. It is the matterstore. Actually, I realized yesterday that matterstore is actually an API. While I saw one of the talks in SQL, it's not that. It's a schema registry that we create. And that is to move everybody towards a contract-first approach. Instead of like generating code, or even if they generate code, that we have a safety net. We are now also like so many years later, so gRPC is back on the table in our architecture. Microsoft even does like in .NET Core 3.0. It's still in preview, but they're doing a lot of work with gRPC. They are really contributing, and they're making that new version 3 ready for gRPC. And again, like, why not if you're using gRPC? Use it first. So first, safety first. If you're going to do contract first, we want to have a safety net. And there are two types that is kind of safety net. There are a lot of conventions that in Proto makes it life easier. We want to have like a tool that, for example, you use like, there's a convention that if you have a message that you have to use Pascal case. If you have a field, you use snake case. In gRPC, the convention is you have a request and response at the end. Those are kind of linting rules. We want to actually check that up. So in our schema registry that we built, we do linting to make sure those things are there. So if you make a contract written by hand, there's some interlude though. If I hear on the gRPC conference that within Google, if you are higher up the stack and you're working on APIs or something, you're working most of the time in the proto schemas. So in the proto buff schema. So you should actually teach people inside to work like with a contract first. You also have like a disconnect from the code, and that's actually a good thing. So that's linting. Also important, I have some examples. Another thing, for example, contract leakage. Another convention is when you go from a version 1 to 2, if you do a breaking change, you copy everything over. You should not include something from your version 2 from version 1. Those things we want to actually check. That's the one I already told. And then diffing, we want to make sure that schema evolution is tackled. So making sure that you don't change like an int to a string. That you maybe only add fields. And that if you want to remove a field, that you first deprecate them for a while and so on. We all want to check that in our schema registry. Then something I think quite unique is the shadow contracts. You saw like in my previous proto example with annotations, is this one. There was like a mix of like operational data and like pure technical data for like data engineers. This is like produced by the people working on the microservice. They own this. So that's the fields they own. Also descriptions, they should be able to set the descriptions. But they don't care how this looks into BigQuery. That's not their business. They don't care at all. That's something for us. But we want to keep them managing their contracts. And we don't want to mingle with their contracts. So we actually built in a feature in our schema registry that's called shadow contracts. It's like, okay, let's add fields for us. Technical fields, but we manage that. So we have our normal contracts, they live here. And our contracts live there. It's like just a copy that we are able to add those technical fields that are here displayed in red. Right? So what does the schema registry do? It just does a delta. It knows, I only have to add this and this and this. That's what the difference is. Then when there's like normal schema evolution, like adding fields, for example, or saving something, they are adding it here. And what does the schema registry do? It does apply the delta, our 3 extra fields, and we have it here as well. And that's how we can get like the disconnect from the operational contracts and the contracts for big data or data. We're calling ourselves the data team and not the big data team. How does this workflow work, for example, for the safety net? So depending how you're working in multiple repos or multi-repo, I'll show you a monorepo example, for example. If people like do a change, they do that in a feature branch. In CI/CD, it calls out to the matterstore. Hey, there's a breaking change. The feature branch fails, and that means that they have to look again to that contract. If we're happy, then they are able to merge into that, and actually everything is synced in the matterstore. There's only one for data. This is the reality we're working on. What mostly the operational people do is like just work here. It's like just a Git repo. If you have like very, very big teams, you can do it like this as well. Each team owns their own contracts, and they just publish it to the matterstore. You can say, this package like X, company X dot cards. This is the department that works on cards. They own that package, and they can manage those things as well. And they just publish it. And we see a view of all the contracts here. And nice, important for our, at the end when we bring everything together, every time there's a contract change, we have a change notification. So the architecture there, I'm going to quickly over that. It's like, again, the descriptor, a very powerful mechanism in Proton. And everything supports that. So it's the binary version of your schema. Gradle supports that, Bazel supports that, every kind of mechanism supports creating those descriptors or adding them to the class. It's built into Proton. So we're using those descriptors to get to you. So the architecture is quite simple. So you do a gRPC call, the linter kicks in before even differ. Then the differ is that the storage we're using, it's pluggable, but we're using a Google Cloud storage to have one blob that describes all the contracts together. Then we have a profile. The profile depends on what kind of use cases. We actually don't want to break anything. We don't want to actually that people are able to remove fields at all, and that depends on the profile. And this is running inside CD normally, and it says yeah, there's an error, yes or no, and that breaks the pipe. A nice feature that we have is this component without a user interface. We're using Git actually, so we're dumping everything back into Git, and then we have like a nice history of what's happened. What enables something like that? Because, yeah, it enables not only that you have all the contracts in one place, you have an API to manipulate those things, but once you have something like this, you can do auditing as well. Auditing is very important if you're making sure that actually producers are not lagging behind. I'm going into this a bit deeper. So, you have normally artifacts is for the producers, so the microservice, for example. They're actually having a CI/CD kicked in, the schemas inside. Eventually, you have an artifact as a producer, so the microservice, it has the contracts that they're working with. It's compiled in there. What should like the producer do? It's like ping to the matterstore, make sure that does the contract equals the one that we expect. For example, if you are a developer and wants to sneak in a producer with your own dirty compiled contracts, this will make sure that it will never get into production. So it only starts when it checked the contracts and the matterstore is happy. So we don't get like corrupt contracts into production. The nice thing is also you can ping like daily, for example, and do an audit trail. And with those things, with that audit trail, you can write like tools to see out the logs and do something typically like a microservice. There's a contract evolution as an example. There are 2 fields added. Now, 5 months from now, the producer isn't even like those fields never show up. Then you can actually do those rules, look at the audit log and see, hey, there's something wrong, and actually mail your teams. That's what we actually want. That we have like a system that looks at the contract evolution, see if there's microservices lagging behind. And we can all do that with like a common schema. So the takeaways there like is It's a good tool to safeguard against schema evolution. Shadow registry is an important part of what we are building. After that, to make sure that the configuration is disconnected near the contract, but disconnected from the people that write those things. Change notification. Then the last building block is the schema awareness. So building block 1 was the proto beam that we created. But we created that while schema awareness was actually evolving and becoming mainstream. So we used the learnings there to actually see, okay, that's what we need to actually start using that information to create a pull request for Beam. So once you have those schemas inside, so you can actually do a lot more. So schema-aware PCollections means that you work with a row. Once you have a row or your elements are schema-aware, you can use a lot of built-in primitives or transforms, like those ones, that you can really do on your element. Even it's like in your pipeline you're working with your proto file or avro file or whatever, you can use those, like join, casts, convert, filter, looking like it's a row. The row is like this. So now I'm going to dive a bit deeper of what schema awareness means. It's a very nice system, because if you think naively, if you say I'm converting my proto or avro or whatever in a row, you would think like it's a very destructive thing, but it's not. It's just actually a wrapper around your message that's still natively. It adds a schema, but it also adds like a translation layer. Meaning for the first element, you have a getter. If it's like the string, this says it's a string. It's an array. This is a translation layer for your array, and so on and so on. So it's not destructive. This is fixed, and this is your data. And then you can do like the row filter example. So I have like the UFO example. I create some parts. You set a schema like this, and then you can just look at this as a row where field name is this. It's a double in that latitude. While this is, you can do it on everything that's schema aware, and that's because you go through the translation layer. So the last field here is the double that you want to do your translation on. It goes through the getter layer, then there's a get in your proto, and voila. So it's not destructive at all. So it keeps the proto as is. But it doesn't mean that every operation is not destructive. For example, if you do like a select, you only select like 3 fields in your original structured methods, like the name, latitude, and longitude. Yeah, it's of course destructive, because then it does a complete translation. You get like a new schema with only those 3 elements, new getters and setters, but of course only like those elements. So this is just to show you that what you can all do once you have those schema awareness. So what do you then have to do to actually make your proto, because there's no way currently to make proto schema aware, is create a pull request from Beam. That's the one. That creates this, a schema provider that says, hey, this is the to-row function, the from-row function, and this is how you can have a descriptor translated into a schema. And from there on, everything is schema aware. If you look at how you do have to do it, it's very comparable to what we did with Proto Beam. So from translating from this to the Beam schema, it was very compatible to the plan. But the reason why I picked up the pull request and I wanted to make sure that this comes in. Because remember, I was talking about those options where we can do like things like say, hey, this is the partition field in BigQuery. These are the cluster things. I want to make sure that that is also in the schema. And there's something magic as well in the in Beam schemas, and that's metadata. So what I do is like translate all those options that are in the proto contract into metadata. And once it's in there, you can do again all the magic. I'm not going to dive too deep into this. So now that everything is like you have the proto descriptor. Now you have like an equivalent proto schema with the metadata as well. Then you need something to handle that. And for us, when we created Proto Beam, it also had like baked in those intelligence of handling those options because they were quite fixed. But now we can't rely actually on the Beam pipeline that it knows all those options. But that's where like dynamic transform comes in. We actually create like an extra transform that reads those metadata fields then, what was before option fields. We read them and we automatically convert, like build some big partus inside to make sure that everything is handled correctly. Or sometimes it's just a schema change. So the pull request will actually make sure that the schema gets in. Meta Beam, so that's another thing that will be created as an extension. I hope that also gets into Beam. That will handle those options. And maybe at the end, it could be interesting that there's like a standard set of options. For example, for like handling partitions and so on. But with Meta Beam, I have like a trick to externalize that. I'll just show you an example. So this is like a transform, for example, that can understand those partition fields, cluster fields, descriptions, for example. So I just wrap that to the normal writer I/O. So you create this, and this transforms actually will make sure that it first reads the metadata. So let me do that with an example. So I want to tackle this one, the time partition day. How will I do that if it's like a schema or PCollection with the metadata? So it's very simple. So inside that transform, we just loop over all the fields. Right? So you get the schema, you get all the fields, and then see, get metadata string. The time partition one, what do I have to do then? To the original output, I add the with time partition of actually the name of the field. So you use those metadata to actually transform or change the output. You can do exactly the same with the clustering as well. So use the metadata to add those options. So it doesn't mean that, so you can externalize this thing. Another one, also at those partitions, we had like a problem because we had like a company of more than 10 years old. And BigQuery has like a problem that partitioning has a limited number. If you do it daily, if you have more than 10 years of data, you run out of partitions. So we actually wanted to use this option to actually truncate per month. And then we have like 30 times more partitions available. And we can do that as well, working on the meta. So instead of saying time partition per day, we're doing truncate per month. How would that work with working with metadata? It's like, say that the last field is a timestamp. We normally partition on this one. So, but here we have like the extra metadata. What do? We change the schema. We add a field. And we're saying we're now going to partition on the new fields. And we're adding like a truncate part2 in the dynamic transform. So all that driven by the metadata. Of course, it's a descriptive operation. You don't have like proto anymore because I'm adding a field. So takeaways there, like the schema awareness is it's kind of a game changer for us at least. Instead of having all those things externalized, we can now use the normal beam mechanism. I hope that actually the pull request now lands in 2.17. Yesterday the 2.16 was like branched off, so it doesn't make that version anymore. But the proto handling with the option handling, hopefully it will land on 2.17. And then I start like the examples with BigQuery Meta and the dynamic transform will be an extension library. And we'll see if that gets into Beam as well. I don't want to, it's like general enough that a lot of people could use it. So hopefully it will be accepted as an extension library. Now, getting everything together, of course, those are building blocks within Beam, some standard things that could be used separately, like the matterstore, the proto support, they can all be used together. But we want to actually use that in production for us. So how would like a workflow be used there? So let's say we have like already like an example, an ingestion stream working. It uses the auditing of matterstore just to keep track of what we do. So normal days. It's not that contracts change so much. So do remember that like it's not like generally there's like a lot of development without contract change. Say there's like a new microservice popping up. So that means like in the workflows, those new contracts end up here in the matterstore. Nice feature here. It has like change notification. We have one microservice listening on those changes. It actually includes all the code of the Beam pipeline. It's very small. I'll show you the snippet in a moment. And what it does then, get the contract dynamically. So we're using dynamic messages. So there's no compiling going on here. We get it and create like the new Beam ingestion pipeline automatically, because every information that's there, like what's in there, what's the partition key, what's the clustering, does it have to go to a big table or something, that's all in the contract. And with that small transformation, it can create this new pipeline. And nice thing about this approach is it happens like sometimes weeks before developers are ready, because contract definitions is sometimes way before the code is ready. So the tables are there in BigQuery, everything's okay. And then like maybe like a few weeks later, the producer will be there. It will check are the contracts still valid. It's ready, okay. And you have a new Beam pipeline. Updates are very similar. So like an update, there's a new field in this stream. Change notification. This one knows there's like a new field added. That means this Beam pipeline needs to be updated. So we are using a data flow, and it has an update feature. Maybe Fling does as well, I don't know. And it updates this in place also way before the producer is ever producing those new fields. We'll add new fields in BigQuery or whatever. And you're ready. And then, like, again, weeks later, the producer will be starting adding new fields. So everything's stable again. It kind of looks kind of like a lot of machinery, but if you look at it, like, what are the components here? Like pub, sub, the end are just infrastructure. We look at matterstore actually as a third-party component. It's like, that's why we actually created it as an open source. It's not just part. We see it as a third-party component. So you have the producers. It's part of your daily operations. Those are the microservices. So that's also not so part of the complete solution. It's only this. And the nice thing is, because it's like completely dynamic driven, there's only one kind of pipeline in that microservice, and every time it just spins it up with other contracts. And that's it. And the pipeline will be automatically be driven by all those metadata fields. So it's actually a very simple solution. But this is just a loop, listening to the change notifications. If there's a change, it gets all the data from a matterstore and will spin up those new ingestion pipeline. So how does this one look? So this is just like in a loop, listening to it. We get our metadata here. We have our dynamic transform here that maybe changes some truncation, and the BigQuery metadata will actually add the extra fields like clustering and time. So, wrong title. So this all those things make the schema awareness, the metadata, and having some automatic transforms. It makes our lives way easier. If you look at, like, in the Middle Ages, our pipeline code was huge. Although we did like some things automatically already, now it's only that loop, and that's only actually what it is, except for like the magic happening in those dynamic transforms. But our life is way easier just for the ingestment pipelines. But you have to make sure that your organization is kind of data ready and not just thinks about getting data thrown over the wall. Go contract first, hopefully, and then with some tuning you get like a very simple system. So this is open sourced. matterstore. We're the only one using it. It's very alpha, but for our use case it already kind of works. And actually the rest would hopefully end up just in Beam. If you are interested in those things, I will certainly tweet about it once those things land. So that's a bit it.